This was me testing a 3D printed FPV frame from Drones and Prints. That could have been the end of it, but around the same time I decided to test this frame, I also came across an interesting video about procedurally generated drone frames by Sam. So I decided to try both concepts at once. In this video I'll show you how it went. For the topology optimized frame, I used the same mounting holes as the DP5 frame from Drones and Prints. That way I can simply swap the frame while keeping all the electronics self-contained. I really like this feature, but as I found out later, the weakest part wasn't the drone's arms, it was two plates holding the electronics together. The frame took quite a beating, but it held up well. Compared to DP5 Cross, it was heavier and had noticeable vibrations at lower throttle. They weren't too severe, but I was convinced it could be better. Here you can see vibrations in slow motion along with the black box graphs. So the only logical next step was to generate another version. I spent several days experimenting with different force values, different optimization settings, and targeting specific resonance frequencies. In the end, I was happy enough with the result to print version 2. There isn't much onboard footage because while testing the DP5 version I crashed and destroyed my O3 Air unit. You already saw that at the beginning of the video. So I grabbed an old analog VTX and a camera from RC car I built a while ago and installed them instead. Here is some pretty terrible footage. Then I lost the video signal and drone crashed. The frame survived just fine, but once again, the plates holding the electronics together didn't. Even from that short flight though, I could tell this frame was a big improvement. It had no noticeable vibrations and flew really well, despite all these flat surfaces. Here are the black box logs from the flight. I'm still not finished with this approach, and I think it has the potential to produce some really interesting looking frames that are also easy to 3D print without too many compromises. The problem is that the software I was using was only a trial version and the only plastic material available for optimization was ABS. So I did what any reasonable developer does these days, I started vibe coding. This is an application I'm currently developing specifically for generating 3D printable FPV frames with 3D printing in mind from the very beginning. I don't have any successful frames from it yet, but if it produces something worthwhile, I may make another video about it. I'm also planning to modify version 2 and see if I can shave off some more weight. We'll see how it goes. For now, thanks for watching.
Ja, was